part B. So determine the expected value of x. Well, the expected value of x is equal to the sum between I equals 1 and n of xi and times pi. Now, in this case, pi, we'll just make a note, pi equals 1/16 xi. So this is just now, this just becomes 1 squared over 16 plus 3 squared over 16 plus 5 squared over 16 plus 7 squared over 16. And all of that is equal to 84 over 16, which is, let's see, 5 1/4, I think. Yeah, so, and that's the answer, that's the expected value of x. Now, the expected value of 1 over x is a bit trickier. So we can still use this previous formula, but the probabilities are still the same because this is what the random variable outputs. But now it becomes ei equals 1 to n of 1 over xi times the probability of I. And because our probability of I is a 16th xi, what this basically becomes is a 16th times, because we're going to times all of them by a 16th, that's a common factor, well, xi over xi. So all it's going to be is 1 plus 1 plus, well, 1 over 1 plus 3 over 3 plus 5 over 5 plus 7 over 7, and that's just going to give us 4. So all of this equals 1/4. So that's the expected value of 1 over x. Then we've got to do part C. So for part C, there are actually 2 parts to it. They're not letting you off easy. They tell you to find the probability that x1 plus some second value x2 equals 6. So we go back now to the values that x can output, which are 1, 3, 5, and 7. Well, what combinations can we add to make 6? We can do 1 plus 5 and 3 plus 3. So this thing here, this equals P1 times P5, or sorry, this should be the probability x equals, but I'm not going to go back and change it now, times the probability of 3, and that's just going to be times the probability of 3, so that's just squared. And you can literally just stick numbers into this because you know the probability of getting any individual number just equals k, which is a 16th, times x. So all of this stuff just becomes 19 over 256 when you stick your numbers in, because it's a 16th times 5 16ths, that's 5, plus 9, yeah. So you're just going to get 19 over 256. Okay, so now there's another part to part C. Where they tell you to find the probability that x1 equals x2. This is just another stick your numbers in case, where you just go, right, what's the probability I'm going to get 1 twice, what's the probability I'm going to get 2 twice, 3 twice, 5 twice, and 7 twice, and add them all together. So it's the probability x equals 1 squared, plus the probability x equals 3 squared, plus the probability x equals 5 squared, plus the probability x equals 7 squared. That's all just going to come to 21 over 64. I want to get that question over with because it is just number crunching. in my opinion. The final question I wanted to look at was question 8. And this is a continuous random variable question, so there's a bit of calculus going to come into this. So you're given a probability density function and told to show 8 equals 4. Well, a probability density function, remember, looks something like, if I extend that a bit, looks something like this. It's normally a bell curve. And the area under the probability curve always, this probability density curve, always equals 1. And this area is given by an integral between bounds of, well, for this question it's 1 and 0 because we're told that there is only any probability of getting x for values between 1 and 0 inclusive of the function we're given, which is kx lots of 1 minus x squared dx. And because we're told this, because we know it's a probability function, this area equals 1. So now we can actually just integrate and find x. So to integrate this function, what do we do? Well, there are a couple of ways you can do it. You can expand the brackets and then integrate, but the head and short of it is you're going to get this. You're going to get kx squared over 2 plus kx to the 4th. Oh, sorry, minus kx to the 4th. If I could even do symbols properly. Kx to the 4th over 4 between 1 and 0 equals 1. And then you're just going to plug all that in and find k over 2 minus k over 4 equals 1, and find k over 4 equals 1. And therefore k equals 4, and this is what you were aiming to show. Part B. Right, so now you're told to find the expected value of x. Well, the expected value of a probability density function is the integral between the bounds you're given, that's 1 and 0, of x f of x, which is x lots of kx 1 minus x squared dx. And again, this is just some number crunching, but you're going to put all this in and you're going to get, and you can do this yourself if you want to check, 4x cubed over 3 minus 4x to the 5th over 5 between 1 and 0, which is going to give you 8/15. And that's the answer to part B. And there's only one part left on my list now, that's part C, where we're told to deal with cumulative density functions. To go from a probability density function, if I just draw that graph again, looks something, extend my axes again, so this is a bell curve, that's not brilliantly drawn, to a cumulative density function, which is normally something like this. All you do is integrate. So to get from there to there, you integrate. I'm just going to put int. And to go the other way, you differentiate. But just as integration is the opposite of differentiation. So anyway, if we just get rid of those arrows and this, we're just dealing with cumulative density functions now, so I can write down the side. So we're trying to find capital F of x. And capital F of x is going to equal the integral between, and we're going to get a function of x. And basically what it's going to be for a cumulative density function, we're going to have some sliding value going up this axis, just our x value, and it's going to be the integral between 0 on our probability density function and this value x of our function, which was now k we know is 4, so we can plug that in. We can't anymore put an x in this function because remember we're going to be plugging x's in from our bounds. So I'm going to use t and say 4t 1 minus t squared with respects to t. And then out of all of that, you're going to get 2 t squared minus t to the 4th between x and 0. And I think it's quite easy to see that this is just 2x squared minus x to the 4th. And there we go. You've now found a function for the cumulative density graph in terms of x. That's part I done just by integrating. In part II, excuse the wonky dots, we're told to find the probability that 0.25 is less than or equal to x, which is less than or equal to 0.75. Well, this is a good question for a cumulative density graph to solve, because the cumulative density graph basically gives the probability that x is less than some value or equal to it. So we could just do f of 0.75, and that would give us the probability x is less than 0.75, but it's also got to be greater than 0.25. So we then have to take away f of 0.25. And this is just another calculator job. You just type all these numbers into this function, substituting 0.75 for x and then 0.25 for x. But basically, once you've done all that, you're going to get 0.6875, if I've done my maths right at least. And that's your answer. For part 3 then, the last part of this paper, you're told to find the median value of x. And the median occurs when this cumulative density graph is at 0.5. So that is to say, we're looking for the point where 2x to the 4th, 2x squared, sorry, minus x to the 4th equals 0.5. So therefore 2x to the 2x to the 4th. I've skipped some algebra steps here, so it might be worth just trying to get to this yourself. But plus 1 equals, neaten this up, plus 1 equals 0. All I've done is added x to the 4th and taken away x squared and then doubled. And this is actually, might seem very familiar to you. It's like a quadratic, except your powers of x's have doubled. So let's say I said u equals x squared. Then I could write that 2u squared minus 4u plus 1 equals 0. And now I've got a quadratic. And you can't factorise this. Thankfully, I hate factorising. So I'm going to use the quadratic formula. And you're going to find u equals 4 plus or minus root 8 all over 4. And x equals the square root of u, When you type all that into your calculator, you're going to get x equals 1.307, and I'm just doing this to 3dp, or 0.541. And if we look back to our bounds that were given in the question, this is only valid, this function is only valid for x values between 1 and 0. Any other x value, just the probability is 0. So this value here gets a big fat cross, and 0.541 becomes our median value for this function. And that's the last question I wanted to go through for this paper. So thanks for watching.